All right, here we go. Now we've got day 2 of solving systems of equations. So what we're going to do in this in this lesson is we're going to introduce this concept of elimination that is meant to, I think, be an alternate to substitution, and I think it's a quicker and a more straightforward alternate to substitution. I personally prefer this, and I think many of you will as well. So I think the best way to go about this is just to try to do some of these. Before we do, let's read our little note here. It says you can use the elimination method to solve a system when one of the variables has the same coefficient in both equations. So that's going to be kind of important there. And we're going to kind of talk about what that looks like. And I'm going to put a little spin on that. All right. So it says step 1 is to multiply one or both equations by a number to result in 2 equations that contain opposite terms. Now we're going to talk opposite terms. What they mean is that you want things that are going to add up to 0, right? You want 2 terms that add up to 0. And so the only way you can get that with terms is with variables, is if you have 2x, then the opposite term would have to be negative 2x because it has to add up to 0, not multiply to 0, but add up to 0. So basically what it's always going to be is the term for that is additive inverse, right? So that's what we're looking for. We're looking for the additive inverse when we do these, and then and we'll have to manipulate the equations a little bit to get that. Then once you do that, you add the equations up, and then one of the variables will consequently be eliminated. So that's why it's called elimination. And then you just solve what's left. And then you do what you did before, where you plug into the one of the other equations to solve for the other variable. So we're going to look at 3 different kind of looks for this, right? So this first one, right, is kind of set up for us already. So we got 4x minus 3y equals 29, and we got 4x plus 3y equals 35. Well, we've got a negative 3y and a positive 3y here. And I know from looking at that, hey, if I were to add these 2 together, that would get rid of the y. So this thing's all set. You know, negative 3y and positive 3y are additive inverses of each other. So we are going to not do any rewriting with these equations, and we're just going to add these 2 things up and see what we get. So when you add 4x and 4x, you get 8x. When you add your y's, they cancel, which is what we want. And then 29 plus 35 is 64. So then you solve for x, divide by 8, and you get x is equal to 8. So right away, this is 1,000 times easier than substitution, at least in this example. And then you can take either one of these equations and plug 8 in and see what you get. So let's, I don't know, let's do the bottom one, right? So we'll go 4 times 8 plus 3y equals 35. So I just plugged 8 in for x into this equation right here. This gives me 32 plus 3y equals 35. Now we will subtract 32 from both sides. That gives me 3 is equal to 3y. And if you divide by 3, you get y is equal to 1. All right, sweet. So we've got the point 8, 1. All right, the point 8, 1. Now what you can do when you get this is you can take this point and you can plug it in here and see if it still works. So if I go 4 times 8, it's 32. And then 3 times 1 is 3. So is 32 minus 3 equal to 29? Yeah, it is. So it checks out, right? And that is your solution. So it's kind of a straightforward way of doing this. So I think in the same video, I'm gonna do another example for you. So we've got this one right here. All right. Now my 3y and my 3y are exactly the same, so they are not additive inverses of each other. So when you have that kind of situation, what you're going to do is you're going to say, well, how can I make one of these negative so that, in this case, so that they do add up to be 0? So that's easy. We know how to do that. Let's just multiply one of them. Let's take the top one and let's multiply it by -1, and let's see what happens. All right. So when I do that, I get negative 5x minus 3y is equal to positive 19, All right, so everything just basically changed signs. That's all we did. We said we're taking the inverse of that. Then you're going to add that to 8x plus 3y equals negative 25. All right, this is not bad. So we got positive 8, negative 5. You're going to get 3x. These cancel, and then you get negative 6. So continuing to solve for x, we would get x is equal to negative 2. All right. So now let's plug negative 2 into this equation right here. It doesn't matter which one. Let's just use the top one because I just don't want to think about it and just want to do it. Right. So there we go. We got 5 times negative 2 plus 3y is equal to negative 19. So that gives you negative 10 plus 3y is equal to negative 19. Let's add 10 to both sides. So that gives me 3y is equal to negative 9. And then we divide by 3 and get y is equal to negative 3. So my solution is the point negative 2, negative 3. And just to make sure I'm not completely wacky here, I'm going to take this solution right here and I'm going to put it back into the other equation. I'm going to put it in here and see what I get. So you get 8 times negative 2 plus 3 times negative 3. And if I did this right, that should equal negative 25. Well, negative 16 and negative 9 actually do add up to be negative 25. So yes, it works, and it works fantastically. So hope this is helpful. I'm going to stop the video just because it's getting a little long. And then in the last video, we're going to do one where we're going to have to do some multiplying first.